ability to use this particular vaccine against other coronaviruses is something that will definitely be tested, because the goal, of course, is to have one on the shelf that you could use against the next virus that might emerge, as well as the one that we're currently dealing with. SARS took a long time to emerge, and the scientific data emerged very slowly because it was very new. This response differs in that data was on the virus was rapidly available online and has been able to be shared across nations, so that scientists in multiple countries who are interested in working on these viruses and really want to respond to the public health crisis are in ability to rapidly design vaccines, test antivirals, and think about mechanisms for intervention with the virus.
We need to be able to supply the NIH, the National Institute of Health, with enough material, not to treat everybody, but to run a study and show that it works. And once we can do that, then the next question will be, okay, how do we scale up? How do we make it accessible to people? It's very quick to go from digital information of here's what the protein is, to go design what the antigen is. And that's what makes our technology unique. Our starting material is zeros and ones. It's digital. It's the information that's required. It's the software of life that's required to actually translate into a protein, but I don't need to actually have the physical protein. Our vaccines are not live vaccines. They don't replicate. It's basically just giving you the information for your cells to make the protein that then would be recognized by the immune system.
It's not an issue of if, but when. I think that these will occur again. Am I surprised every time it happens? Yes, I'm not. I am. But I think it demonstrates the capacity of these viruses to cause really serious disease, not just medical or health disease, but social disruption. And I think there's really, really many reasons to keep an emphasis on the research in these viruses.